So the last section we have in this particular chapter is now solving a radical equation. So when you have a radical equation, what that means is you now have an equal sign in it. We've had all expressions so far where there's been no equal sign. So the steps are that we want to follow. It says to solve a radical equation, first, we're going to isolate the radical. Second, we're going to raise each side of the equation to a power equal to the index of the radical to eliminate the radical. Third, we're going to solve the equation. And fourth, we're going to check our solution. So step 1, isolate the radical. So the 1's got to move over. Step 2, in order to get rid of a square root, we're going to square it. So what we do to one side, we do to the other. And a square root and a square cancel each other out. And then when we solve, we get y is equal to 38. Now, you always have to make sure that you check. So if we sub 38 into this original problem, we get the square root of 36 minus 1 equals 5, and 6 minus 1 equals 5, which is true. So that means 38 is our answer for this one. Now, an extraneous solution is when a result does not make the original equation true, which means when you check it, it doesn't work out. So for this one, we have 2 square roots, so you can't really isolate. So the one that has multiple terms under it, keep that one by itself. But on the right-hand side, we're good. So we're going to square both sides. The left-hand side is the easy side. The right-hand side, though, there are 2 of them. So we're going to have to FOIL these out. So when we FOIL them out, let me get rid of this. We end up with 4 minus 2 radical x minus 2 radical x, and radical x times radical x is x. What does cancel here is the x here and the x here. So I have negative 12 equals 4 minus 4 radical x, and I still have a radical, so I'm going to have to get rid of it. So let's start isolating that radical. So I get radical x equals a positive 4. Now in order to get rid of the radical, here's a second square, and I get x equal to 16. So now when we check, and again, you check in the original, so 16 is going to get subbed in to the original problem. So I get the square root of 4 equals 2 minus 4. 2 is equal to negative 2. Well, that's not true. So in this case, because 16 was the only answer, and it doesn't work out, you have no solution here. So 16 would be considered an extraneous solution because it doesn't work out. All right, on the back here. So you can also, again, you'll see rational exponents being used. It does not always have to look like a radical. So you're doing the same mentality. So if it helps you to rewrite it as a radical, do it. So like this one, we can make it the third root of 3y plus 1 plus 5 equals 0. All right? So then we're going to move the 5 to the other side because you always have to isolate first. Now you get a negative. Now some people might say, well, I can't go any further. You can, though, because it's an odd root. You're taking the odd index with the radical sign. It's not even. If it was even, then it's no solution, but you're not done yet. So now, instead of squaring both sides, we're going to cube both sides because we have to get rid of that 3. So the left side is 3y plus 1. The right side is negative 125. So you get 3y equals negative 126, which means y is negative 42. So now we're going to check. So again, you can sub it into your modified one where you changed it, or sub it into the original. They're the same problem anyway. So we get the third root of negative 125 plus 5 equals 0. So this is negative 5 plus 5, and 0 does equal 0. So that checks out. So your answer would then be negative 42, and that works out. So you can apply the methods used to solve square and cubed root equations to solve equations with any index. So again, to undo something, you would then have to raise it to that power. So if I take this problem, step 1, just like step 1 always, is you have to isolate the radical no matter what. So I'm going to move the 4 over first. This is a 6. Oops, I wrote the 6 in the wrong spot. So I'm going to move the 4 over first, so I get 14. Then I'm going to divide by the 7. So when I divide by 7, this 6 root is now going to be equal to 2. Now in order to get rid of the 6 root, though, I have to raise both sides to the 6th power. Left side is easy, and then 2 to the 6 is 64. and now it becomes a two-step equation in terms of solving, and you get m is equal to 12. You still, though,